We've learned about a lot of different kinds of transformations, and in this video we're going to learn how to combine them. So here's our first problem. The point P is rotated 90 degrees counterclockwise about the origin, and then reflected over the x-axis. Draw the resulting point P'. Why don't we just take this one step at a time? So first we'll worry about rotating 90 degrees counterclockwise about the origin. A 90 degrees counterclockwise rotation about the origin is given by the following transformation. We take a point x, y, and we map that into a new point. And the new point we get by switching the x and y coordinates, so y, x, but we tack on a negative to the new x coordinate, so negative y, x. So let's apply this to the point P. P is the point 1, 3, so we can just stick that into this rule and see what comes out. So the point P, 1, 3 gets mapped to negative of the y coordinate, so negative 3, and then just the x coordinate, so negative 3, 1. So let's plot that on our graph. Negative 3, 1, 2, 3, up 1. There we go. Okay, so how about the next transformation? Reflected over the x-axis. So reflecting over the x-axis, that involves starting with a point x, y, and then mapping that to a point which has the same x-coordinate, but has the y-coordinate flipped sign, so negative y. Let's apply that to our intermediate point here, which is given by negative 3, 1. We just stick that into this rule. Negative 3, 1 is mapped to the new point, which have the same x-coordinate, so x-coordinate stays at negative 3, but the y-coordinate flips sign. So instead of 1, we have negative 1. So there we go. There's our point P'. Negative 3, negative 1. On to the next problem. The segment LM, right here, is dilated with respect to the origin with a scale factor of 3, and then reflected over the line y equals x. Draw the resulting segment L', M'. Again, let's just take these transformations one at a time. So first of all, let's think about dilated with respect to the origin with a scale factor of 3. We know that transformation involves starting with a point x, y, and then multiplying the x and y coordinates by 3. So xy goes to 3x, 3y. So let's go ahead and apply that to each of these points. So the point L is given by negative 1, negative 2. So let's plug that into here. So L, negative 1, negative 2, gets mapped to an intermediate point, and the mapping there is just multiplying the x coordinate by 3, so negative 1 times 3 is negative 3, and the y coordinate by 3 also, so negative 2 times 3 is negative 6. So L gets mapped to this point negative 3, negative 6. 1, 2, 3, 4, 5, 6. So this is the new point. And let's do the same thing for M. So M currently is the point 1, 2, 3, and then down 1, so 3, negative 1. We stick that into this rule. The point M, 3, negative 1 gets mapped to the point with 3 times the x coordinate. 3 times 3 is 9, and then 3 times the y coordinate. 3 times negative 1 is negative 3. So let's plot that. 9, negative 3. So there's 5, 6, 7, 8, 9, and then down 3. 1, 2, 3. So there's our new point. Why don't we label these points also? That one was negative 3, negative 6, and this one is 9, negative 3. And we can connect them up to find that intermediate segment. So this is just after the first transformation, which is the dilation. Alright, now let's think about the next transformation, reflected over the line y equals x. So why don't we draw the line y equals x so that we can see what's going on here. We're reflecting over this line, so let's draw it. It goes through the origin with a slope of 1, so let's make it go through the origin, then run through that first, second, third diagonal points, and let's draw that with a dotted line. So drawing dotted line going forward and the dotted line going backwards as well. So that's the line y equals x, and we want to reflect over that line. Reflecting over the line y equals x is pretty straightforward. If we have a point xy that we want to reflect over, all we have to do is switch the x and y coordinates. So point xy goes to the point yx. So let's do that with each of our points here. The point -3, -6 goes to the point which has those coordinates switched. So -6, -3. Let's plot that. -6 is, -5 is here, so -6 is here, and then -3 is down 1, 2, 3. So that's the point -6, -3. And let's do it with the other point also. The other point is 9, -3. And that point gets mapped to the point which has those coordinates switched. So -3, 9. And let's plot that. -3 is -1, -2, -3, and then up 9. So up, big tick mark is 5, then 6, 7, 8, 9. So there we are. There's the point -3, 9. We should also label these points. So L started at -1, -2, then that went to -3, -6, and then that went to -6, -3. So L prime is this point right here. Likewise, the point M, which was at 3, -1, went to 9, -3, and then that point went to -3, 9. So this is the point M prime, -3, 9. And lastly, we can just connect L prime and M prime to make the segment L prime, M prime. There it is. And finally, we're done. Here's our final problem. The triangle ABC is transformed subsequently by the following functions. The function t takes points xy to the points x minus 3, y plus 2, and the function u takes points xy to the points x over 2, 3y. And we want to draw the resulting triangle A prime, B prime, C prime. First, let's go ahead and apply the transformation t to each of these points. So first of all, we'll need to find the coordinates of A, B, and C and plug them into t. The coordinates of A are -1, -1. And then the coordinates of B are 1, 1. And the coordinates of C are 5, -1. Now we can go ahead and apply that function t. So t of, let's take the point A to start with. T of -1, -1 comes out to be x minus 3. So -1 minus 3, which is -4. Y plus 2. So -1 plus 2, which is 1. Why don't we plot that? -4, 1. So right over here. We can label that too as -4, 1. And now let's move on to B. So applying the function t to the point B, which is 1, 1, results in the point 1 minus 3, so -2, and then 1 plus 2, which is 3. So plot that, -2, and up 3, right over here. Lastly, the point C is 5, -1, so applying t to that point 5, -1 gives us the point 5 minus 3, which is 2, and then -1 plus 2, which is 1. So that brings us to this point right here, 2, 1. And let's wait until we apply the next transformation before connecting the points, just to keep the graph nice and clean. Now the next transformation is u, which takes a point xy and brings it to x over 2, 3y. So we'll have to apply u to each of these transformed points. First of all, let's apply u to the point -4, 1. So u of -4, 1 is equal to, well, x divided by 2, so -4 divided by 2, which is just -2, and then 3y, so 3 times 1, which is 3. So -2, 3. So this point actually moves over here up to where this point was. And that all comes from the point A, so this is A prime, -2, 3. Alright, so let's go ahead and apply u to the next point. The next point is the point that B was transformed into, which is negative 2, 3. U of negative 2, 3 is equal to x divided by 2, so negative 2 divided by 2, which is negative 1, and then 3y, so 3 times 3, which is 9. So negative 1, 9. So backwards negative 1, then up 5, that's 10, so this is 9. And that's the point B prime. So B prime, negative 1, 9. Last point, let's apply U to the point that C was transformed into. C was brought to 2, 1, so we plug in 2, 1 into U, and we get the x-coordinate 2 divided by 2, so that's 1, and then 3 times the y-coordinate, so 3 times 1, which is 3. So 1, 3, that's our point C prime. And finally, we can just connect up this triangle, connect A prime to B prime, right here, and then B prime to C prime, over here, and then C prime back to A prime, over here. And there we have it, we're done. So now we know how to combine transformations, and in the future we'll learn about symmetry, the idea that an object might remain unchanged even after a transformation.